So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and Mastermind Schools. So, welcome, Mudi Malkapur branch. So, once again, I welcome all the participants of class 8 students for today's session. As you all well aware, and you can see on the screen, my subject is physics. We are in class 8th, our ongoing chapter, electric current. That is a chapter number 6. Today we are entering into the session number 2. So for your information, this chapter is for the syllabus for the test number 6, which is on 30th December. So already we completed the first session of this chapter on Tuesday, where we learn about the basic concept of electric current, some important terms like, for example, what is electric current, right? So what is electric charges? Okay. And now today some more terms we'll discuss. Along with that, we'll go for what is the Ohm's law. Very important concept in the electric current, right? So when you move to so very good morning, good Malkapur. So when you move to the next slide here. So what we already learned about electric current, I already told you, electric current is nothing but it is already 2600 years back. A great Greek philosopher named Thales introduced the word electricity, right? From that, he came to know that there are two types of electric charges. There are two types of electric charges, which are positive charge and negative charge. Because generally, atom is electrically neutral. Any atom contains same number of positive charges and same number of negative charges. So positive charges are fixed at the center, which cannot be moved because of their heavy mass. But negative charges can be transferred from one body to another. So whenever there is a transfer of energy takes place, either by friction or by conduction or by induction, the body becomes charged, positive or negative. Okay. So this flow of charge, the rate of flow of charge or flow of charge per unit time is defined as electric current. So electric current is mathematically given by I is equal to Q by T. So what is Q here? Q is nothing but charge, either positive or negative. T is nothing but time. So charge per time is called current. So charge you generally measure in the unit called coulomb. You might have seen in the lower classes. And time is measured in second. So current is measured by coulomb by second, or the standard unit is ampere, the name of the scientist. Ampere is the standard unit of electric current. Right? Clear? The rate of flow of charge. Either charge may be electron or charge may be proton, or positive or negative. But generally in electric current, what we consider is flow of positive charge only, because positive charge is having the high potential compared to negative. Okay. So this is about the very important first or basic mathematical formula in electricity. I is equal to Q by T, or I is equal to charge by time, or I is equal to coulomb by second, or simply ampere. And this current is measured by using an ammeter. Ammeter is a device used to measure the current. Ammeter to measure the electric current. Okay. So welcome, Mastermind Faraknama. Clear? Right. So already we have seen in the last class. Along with that, some more terms we'll see after knowing about the electric current, units of electric and everything I explained you. Okay. So direction always from positive to negative only. The current always flows from positive to So positive to negative. Because positive is the higher potential, negative is the lower potential. So current always pass from the higher potential, lower potential, and is measured by ammeter. I told ammeter is here, see. So with the help of ammeter, we can measure the how much current is flowing through the wire. Okay. So you can see here ammeter. The deflection of the needle indicates the reading. So when you see the any TV mechanics or any mechanic come to your house, he'll carry a meter to check the current. When the two wires are joined together there, you can find the deflection of the needle of ammeter. A, we written as A. Okay. So ampere is a unit, and a small unit also you can write microampere, milliamperes, microamperes, many see. Micro means 10 power minus 6 ampere. Milliampere, 10 power minus 3 ampere. The smaller units of the current. Okay. So 1 coulomb contains, see how many electrons. Very important point again. So 1 coulomb is nothing but 6.25 into 10 power 24 electrons. 26 electrons. Means that many electrons constitute 1 coulomb of charge. When that many electrons passes through, we can find that the 1 coulomb of charge is there. And 1 coulomb of charging, how speed it is traveling, current is producing. Right. So this is totally about the electric current and its value. Now some more terminology will come across, like for example, you can see electric potential. So already you know this formula I shown, I by T, Q by T. Potential, what is potential? Potential is nothing but capacity, tendency, ability. So in which direction current is flowing? To know such property, the physical state of matter is called electrical potential. Right? Electrical potential is nothing but V is equal to W by Q. The work by charge. To move a charge, some work is done. That work by charge is called potential of electric potential. Suppose I am switch on the switch here. So charge is flowing and bulb is glowing there. So to move a charge from switch to bulb, there should be some work done because there is a displacement is there. Electron is moving. So that potential is called electric potential, mathematically given by V is equal to W by Q. Q either small or capital. So W is nothing but work, Q is nothing but charge. We know work is measured in joule and charge is measured in coulomb. Right? Coulomb is the name of the scientist again. Our standard measurement of electric potential is volt. Again, named after the scientist, Volta. So volt is and there is a voltmeter. Voltmeter to measure the electric potential. How much capacity is there between the 2 points is measured by voltmeter. Ammeter to electric current, voltmeter to electric potential. Which is measured in, which is mathematically V is equal to W by Q. There is a second important formula of electricity. So finally, I'll give synopsis for you. Don't worry. Okay. Then potential difference, another important term, which is simply called PD. Same. Potential or potential difference are same. The amount of work done to carry a charge from higher potential to lower potential. So higher potential is positive and lower potential is negative. When the charge carrying from here to here, the amount of work done is called, because some force is applied here and body's displacement is there. So definitely work is done. W is equal to F into S. To carry a current from switch to the fan, switch to the electric bulb is called potential difference. Same as a potential, it is also given by V is equal to W by Q and measured in volt. The difference, that is the amount of work done to carry a charge from higher potential to lower potential. So as per the convention, even heat also flow from hot body to cold body, water flow from high level to low level, air flows from high pressure to low pressure. Similarly, current also flows from higher potential to lower potential, that is positive to negative. And that work done to carry the positive to negative is called potential difference. Very important. So we learned three important definitions now. Number one is electric current. Number two is electric current is the first one with formula. I is equal to Q by T. Number two is electric potential. And number three is potential difference. You can call it as PD. That is V is equal to W by Q. This is common for both. It is measured in volt. Electric current is measured in ampere and is measured by ammeter. Right? It is measured by voltmeter. Okay, this is the basic terminology when you are learning about the electric current. Right? Now we'll move to the next part, next slide, where we learn about the relationship between the, very important. So relationship, that is second synopsis we are in. So we know that there is we know the value of V. P is nothing but potential difference. I is the electric current. The relationship between these two is given by Ohm's law. The relationship between strength of electric current and potential difference or electric potential is given by the famous law called Ohm's law. Ohm is the name of the scientist who proposed this law. So before going for the explanation, let me show you video on the explanation part of the Ohm's law. Then I'll give the explanation for the explanation and mathematical derivation on the Ohm's law, right? Just keep watching the video first about the Ohm's law.
Hey there guys, Paul here from theengineeringmindset.com. In this video, we're going to be looking at Ohm's law to understand how it works as well as how to use it. There are also two problems at the end of this video for you to test your knowledge and see if you can solve. So what is Ohm's law? Ohm's law is the relationship between voltage, current and resistance and how they relate to each other. Ohm's law was developed by a German physicist named George Ohm, who undertook many experiments to develop his theory, including measuring current by touching live electrical circuits to see how much it hurt. As you might imagine, the higher the current, the more it hurt. Now there are three formulas we need to use for Ohm's law, but we don't actually need to remember these, and I'll show you a super easy tip in just a moment. So the three formulas we use for Ohm's law are voltage equals current multiplied by resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. If that seems like a lot to remember, then don't worry, because we don't need to remember them. All you need to remember is Ohm's triangle, which looks like this. So you just need to remember these three letters in order, V, I, R.
So right here we have a demonstration, basically cluster demo. Based out.
Okay. Then we just write those letters in a triangle with V at the top, and we draw a line to separate the letters. In fact, you don't even need to remember those because I've made a free PDF guide for you with some worked examples which you can keep on your PC or your mobile and access wherever you need. Links for that can be found in the video description down below. Now all we do when we need to use a formula is cover up the letter we need. So if we want to find the voltage, then we write V equals, and then we cover up the V in the triangle. That leaves us with I and R. So we write I multiplied by R, which means voltage equals current multiplied by resistance. You can write a little multiplication symbol in the triangle between the two letters if it helps you. Now I know what you're thinking, why is current represented with the letter I and not a C for current, or even a letter A for the unit of ampere? Well, the unit of current is the ampere, or the amp, and this is named after André Ampère, a French physicist. A couple of hundred years ago, he undertook lots of experiments, many involved varying the amount of electrical current. So he called this intensity du current, or the intensity of current. So when he published his work, they took the letter I and it became standard until this day. Now you might also come across formulas where the letter E is used instead of V. The letter E stands for EMF, or electromotive force, but don't worry about that. Just stick to using V and substitute V for E if you see it used in Ohm's law questions. Anyway, so by covering V, we get voltage equals current multiplied by resistance. If we want to find current, then we write down I equals, and then we cover up the letter I in the triangle. That gives us V and R. So as V is above the R like a fraction, we can write V divided by R. Therefore, current is equal to voltage divided by resistance. If we want to find resistance, then we write down R equals, and then we cover up R in the triangle. That leaves us with V and I, so we write V divided by I, which gives us resistance equals voltage divided by current. Let's look at some examples for how to use these formulas. First, let's see how we find voltage and how it relates to the other parts. Let's say we have a simple electrical circuit with a battery and a resistor. We don't know what the voltage of the battery is though. The resistor is 3 ohms, and when we connect a multimeter into the circuit, we see that we get a reading of 2 amps of current. We want to find the voltage, so using Ohm's triangle, we can cover up the V, and that gives us V equals I multiplied by R. We know the current is 2 amps, so we can write that in, and we know the resistance is 3 ohms, so we can write that in also. Therefore, 2 amps multiplied by 3 ohms gives us 6 volts. The battery is therefore 6 volts. Now, if you want to check your answers for Ohm's questions, then I've built a free calculator on the website. You can just drop your numbers in and it will do the calculation for you. Links for that again in the video description down below. Coming back to the circuit,
Right.
if we now double
So
the
that is about the Ohm's law, description of the Ohm's law. Let me explain once again for you theoretically. So actually, Ohm's law shows the relationship between V and I. What we have seen V and I formulas, the relationship between potential and current is given by the Ohm's law. So according to the Ohm's law, proposed by the, of course, named after him, Ohm only, at constant temperature, this is very important. At constant temperature, temperature must be constant. If temperature changes, automatically this changes. So at constant temperature, right, V is directly proportional to I. What? V is directly proportional to I. So whenever current is passing through the wire, copper wire or aluminum wire, the potential difference between the one end to other end of the wire is directly proportional to strength of the current. You pass more current, but the potential difference is more. That is, work done is more. So more current, more work done. Less current, less work done. That is, takes place at constant temperature. According to the Ohm's law, at constant temperature, the flow of current is directly proportional to potential difference between the 2 points, or potential difference is directly proportional to current. From this, you got to remove the symbol here, proportionality symbol, use the constant R. R is introduced as a proportionality constant, and which is known as R is nothing but resistance. Resistance means to control the speed of electron, just like a speed breakers. The symbol also like this will be like speed breakers only. Means the resistance controls this. So what is resistance is nothing but V by R, V by I. The potential difference by current will give the resistance value. And this R is measured in units called ohm, the unit of R. So you know unit of I is ampere, unit of V is volt, and unit of R is ohm. The name of the scientist again, the symbol like this, ohm. Right? That is the resistance is a new word introduced during the Ohm's law. So according to the Ohm's law, at constant temperature, the condition is compulsory. It is not applicable everywhere. It is applicable only when the temperature is kept constant. The current flowing through the conducting wire is directly proportional to electric potential. Greater the current passes, greater the electric potential. So it's from that we got the formula V is equal to IR. V is equal to IR, which very famous formula. That is the third formula of this particular chapter. After I is equal to Q by T, the first one is I is equal to Q by T. The second one is V is equal to W by Q. And third is equal to V is equal to IR. So see here, according to the Ohm's law, at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across the ends. From that, you got the formula V is equal to Ri, or V is equal to I, R is equal to V by I, right? I is, see, that only explain the triangle. There is nothing magic. When you need formula with three quantities, you can find out, like easy remember. So you write V here, I here, R here. So it is a division, it is a multiplication. So suppose you want formula for V, place your thumb on V. So you get V is equal to IR. Right? Suppose you want formula for I is equal to V by R. Sometimes confused in changing the right side, left side. I by R. Sorry, V by R. Right? If you want formula for R, place thumb on R is equal to V by I. So by using this formula, you can find out either V or I or R also. By using simple triangle which is named as Ohm's magic triangle. This is used even for the any formulas related to three physical quantities. For example, we have F is equal to MA. So if we have F is equal to MA also, you can use this formula. F here, M and A are here. Right? We can use that also. For any formula related to three terms. V is equal to N lambda. In sound will come across. Okay. For all, you can use this magic triangle. But there is nothing magic, only for easy to remember. Okay. Now, when you go for next explanation. So, last you can see here, there is explanation part. The current is directly proportional to the potential difference. Right? The potential difference across the ends of the conductor is doubled. When potential difference is doubled, the current passing through is also gets doubled. Means, if you increase the current, automatically the potential difference also increases. If the potential difference across the ends of the conductor is halved, the current is also halved. So make it a half, the current also becomes half. So the current is inversely proportional to resistance. So I is equal to V by R now. Okay. So current is directly proportional to voltage and current is inversely proportional. Means when current increases, resistance decreases. When current decreases, resistance increases. Okay. Thus, the strength of electric current flowing is great given conductor depends on two factors. One is potential difference and other one is resistance. Right? So, current is depends mainly on the two factors from this formula. One is potential difference, other one is resistance. These are the two factors where the current depends. Then what is electric resistance? It is a property of the material to control the flow of electron. The property is a property only. Property of the material to control the flow of electron or to slow down the flow of electron is called resistance. So material which is offering resistance is called resistor. See, there are two words. One is resistance, other one is resistor. Like magnet, magnetism. Right? So magnet is a material. Magnetism is a property of the magnet. Similarly, resistor is a material. Resistance is the property of that particular material. Okay. So which is denoted by R and measured in ohm. OHM. The unit of resistance is ohm. OHM and symbol of ohm is like this. We can show. Right. So this is about the complete Ohm's law. What we have seen in the video and what we have gone through the concepts. So there is further explanation is there for this. So we'll continue in the next class actually. So but before that you can see some more information what we are going to learn next. What is resistance is already we have done, and resistance is the opposition allowed by just like a frictional force. Okay, so the property of the conductor by virtue of which it opposes the flow of electric current through it is called resistance. So it is denoted by capital R and unit R ohm. Right? Either volt by ampere or simply ohm. So opposites of resistance is conductance. Conductance means which conduct the electricity. See, resistance we are showing by ohm and symbol is this. But conductance is MHO, mho, and symbol is also reverse. So reciprocal of resistance, that is conduction, is equal to 1 by R, you can write. Reciprocal of resistance is called conductance, which is measured in either mho or even Siemens. Siemens also you can measure, another scientist name. Either you can MHO or simply Siemens, which is the unit for conduction. Clear? So resistance followed by the reciprocal. Opposite to the resistance is conductance. So that's all for today. What we learned today is about the 3-4 important terminologies followed by the complete details of the Ohm's law, where we learn about the. So next class we'll learn about the factors of the resistance. From that also you can get some information. So we'll get what we learn is what is electric current. The homework you can see, home task you can see. So the same thing what we learned today and many more we learned. One is electric current. The second one is electric potential. Third one is potential difference. Fourth one is Ohm's law. And fifth one is resistance. Right. And last one is conductance. Then we'll see next class what is the factors influence the resistance, on what factors resistance depends. Okay. But these are the 6 top definitions we recalled and learned. So the relationship between these two comes under Ohm's law. That is electric current and electric potential is given by Ohm's law, which is V is equal to IR. From this resistance called R is equal to V by I. Current is measured in ampere. Electric potential is measured in volt. Resistance is measured in ohm. And conductance is measured in Siemens. Clear? These are the 6 important terms we learn in the today's session. So we'll continue the same in next class with more and more information about the factors affecting the resistance and probably the effect of electric current also. Okay. So that's all for today. Thank you all of you. Have a wonderful day. Thank you.